Hi, and welcome to Azure Blockchain Desperados. My name is Julia Nathan. I'm a cloud solution architect at Microsoft.
And my name is Bob Jacobs. I'm also a cloud solution architect at Microsoft.
All right, so for today's topic, we are covering secure and reliable client communication with Azure Key Vault. So Bob, this is a mouthful. What are we talking about here and why do we care?
Okay, so yeah, mouthful. Basically, this scenario that we're trying to paint is a more enterprise ready scenario for communication with blockchain. When working with blockchain today, because all transactions need to be cryptographically secure, we have to use public and private keys, and normally those are managed in wallet software, which could be local, it could be on a device or something. For enterprise scenarios, really what we're looking to do is take advantage of Azure Key Vault, which is our HSM service in Azure, to do what it does best, which is to manage keys and secrets on our behalf. So wouldn't it be great if we could take our Azure Key Vault to host our public-private key pair and be able to use that for all of our transactions with blockchain.
Okay, so that sounds pretty good. So in this sense, it's definitely more secure because we are using Azure Key Vault, which can use hardware security modules for high-value keys. It's more reliable because it's an enterprise level service and it's backed by an SLA. Is that about the size of it?
That sounds right. Yeah, sounds good.
Okay. All right. So Bob, I'm super excited to see some of the code and the demo that you have lined up. But before we head in, for all the viewers, there's a few concepts and services that we're assuming you have some familiarity with. And if you don't, there's a lot of really good documentation out there. The first one is Azure's Blockchain Service, and that is an easy way for you to deploy blockchains into the cloud. It's meant for consortium networks because if you use it, you'll see it's got governance built in and consortium management features, and it's a really nice way to let your developers focus on developing applications instead of worrying about the network or administrative type duties. The next service, which you definitely mentioned, is Azure Key Vault. And as we said, this is a secure way to store your secrets and your keys, and it's what we're going to be using today. The last service that we're going to discuss is Azure Functions, and that is basically our event-driven serverless code. So again, you can find documentation in all of these things. So Bob, let's take it away. What do you got?
Okay, let's take a peek. So let's start off. I wanted to point you to the actual GitHub repository, which is going to contain this sample. And the original comes from our friend and colleague Madi, who set up this scenario earlier this summer, because we've been getting quite a lot of questions from customers around this and how to do this. So you'll find the repo that is going to be attached to this recording, so you should be able to have access to it. I'd recommend just scrolling through it. As Julia mentioned, there is some prerequisite knowledge that's required, especially around Azure Blockchain Service. But with that being said, there are instructions on how to get everything set up. So everything that you see, what I've shown you here, you'll be able to recreate just by going through the README. One thing that we did not quite say is for prerequisite knowledge, which will be very, very helpful, is Ethereum. So this sample is written in Ethereum, which is the .NET implementation of any code that runs over an Ethereum protocol. So this is all going to be .NET code. So why don't we take a look at the code that lives in the repository. You should see it up on my screen right now. So I'm in Visual.
Bob.
Good. I'm in Visual Studio Code, and the project is going to be pretty stripped down, so it's going to be easy for you to follow. But what you'll find is 3 Azure Functions, and these Azure Functions serve not only the purpose of communicating externally with an Azure Key Vault, which I'll show you in a second, but it's written in such a way that we're going to genericize all of the functionality of making those blockchain calls. So what you'll find in the code is that it will look in blob storage, and in blob storage, it's going to find a pre-compiled smart contract. So in the sample that I'm going to walk you through, we've already pre-compiled the simple storage smart contract, which if you've done any blockchain development, you should be familiar with. In fact, Let me show you exactly what that looks like. It's pre-compiled right here. We have this running and stored in Azure Blob Storage, and there are two key functions, just a get and a set. As you can guess, get is going to retrieve information off of the smart contract, and set is going to set that value. So we're going to use that to verify that this is working. So we have three functions. You'll see those in a second, but the real meat of what we're looking to do here, actually there's two pieces. One is we're going to grab that pre-compiled ABI, the pre-compiled smart contract, and we're going to stick that, we're going to deserialize that into a dynamic object, and we're going to use that for further communication. So anything that could be compiled can be used. The other key piece that we're using is down here on line 72. So we're using this concept of an external signer. So what's an external signer? An external signer is basically going to, it's an external account. So anything that is outside of the external outside of the blockchain. So we're actually storing our public key and private key in Azure Key Vault, as Julia mentioned earlier. And what you'll notice here is that there's no credentials to communicate with Azure Key Vault. The only thing that we need is the URI, and we're going to be pulling this out of Azure Functions in the application configuration. And the reason we don't need any credentials is because we're going to be using managed service identity in Azure. So what managed service identity is going to allow us to do is, if I go to my Azure Key Vault, what we're going to find is not only have I pre-set up a key here at the point of creation, so there is my key, but I've also set up an access policy where I am giving access to this Azure Key Vault to the Azure function that we're going to be deploying our code in.
So that is actually the managed service identity, right? It's not actually a person, it's a service that's acting.
Yeah. It is, and this is wonderful because developers of the application does not need to know any secrets, any credentials, any bootstrap code to get them in the first place.
Okay, so basically you've shown us the entirety. You can see it all there. You've got your code. There's the functions that are already in there. You've shown us the call for the Key Vault, and so so what happens now?
So what you would do is you would deploy this. I can simply go in and say deploy to function app. And when I do, I'm going to be given the option to find my function app in Azure. Now, you can, there's complete DevOps pipelines in Azure, so this is not a situation where a developer needs to push to production, but this is for convenience and testing and things like this. We do have nice plugins directly into Visual Studio Code to deploy directly.
Deploy it, Bob. Deploy.
We can simply say deploy. In fact, I've actually pre-deployed for time, so let's do that. So in if we go to our Azure function, we have pre-deployed our function right here. So what you'll find is there are three functions already deployed. So the first thing what we're going to do is create a contract. I would pay particular attention to what we are sending over the wire, which is just simple generic JSON. And when I do, it's probably going to take, I don't know, maybe like 8 seconds or so. And what we should find,
as this runs, it's actually using the private key that's been managed by Azure Key Vault, right?
Yep. Okay. That code is pulled. It's gonna the operation is successful.
So anybody who goes out to that GitHub repo can actually can get a copy of this, and they can go ahead and execute everything you've shown us in this demo. And really, it's just a wonderful way for them to see how to implement this feature for themselves in an enterprise and secure manner.
That's right.
Right. Yep. Awesome. All right. So any last words, Bob?
No, I think it's I think it's a good scenario for what you would see in a more real world project. The sample should be good. I'd recommend everybody take a look. Fork it in your own, play with it, familiarize yourself with the various services in Azure and how to integrate them into our blockchain service.
All right. And that's it today from your Desperados. Thank you so much.
Thanks a lot.